Let's take a look at a conditional probability problem. So we've got a contingency table here that is talking about people who got speeding tickets and no speeding tickets, and people who use a cell phone while driving and people who do not use a cell phone while driving. So we can see that if we go across to totals here, all the people who use a cell phone while driving, our total is 305. And if I wanted to know all the people who got no speeding ticket, that's going to be 685. And then in each of these boxes up here, we've got different contingencies happening. So let's look at the first one. Probability that a randomly selected person from here is a cell phone user. Okay, so cell phone user is going to be in this row right here. And if I'm going to choose a randomly selected person, we have 305 people who are cell phone users, and we want to put that over the total. So this one would be 305 over 755. Okay, so again, these are all of my cell phone users. So the total number of cell phone users is 305, and then our total number of people that we're talking about in this problem is 755. Okay, next one. Probability that a randomly selected person has no speeding ticket and is a cell phone user, both things being true. Okay, so our intersection right here is saying that they have to have no speeding ticket and they also have to be cell phone users. So what that's going to be is lining up in our no speeding ticket and our cell phone user column. We're going to match up right here at 280 as our numerator. And then my denominator, again, is going to be the total number of people that we're talking about in this problem, so 755. Okay, now, problem C is different than problem B, and this is where people will get the words "and" from English mixed up with the math symbol that we're talking about. This, our intersection, means that both have to be true. The union here means either no speeding ticket, or they are a cell phone user, or both of them being true. So we want to know what's the probability that a person has no speeding ticket. Okay, person has no speeding ticket. We're in this column right here. No speeding ticket is going to be 685 over our total number, 755. Or cell phone user is this row right here. So we have 305 out of our 755. So I'm going to add those two things together, but if I do that, we're going to end up with some double counting going on. Okay, so no speeding ticket is in this column. They use a cell phone, that's in this column. But then we've also got this number right here for the people who are actually in this row and this column. And so I need to subtract this out because it's getting double counted. So I'm going to say minus 280 over 755. And so this is one of the probability rules that you got. So probability of A plus the probability of B minus the probability of A intersect B. That's what's happening right here. And so if we go ahead and simplify that, we're going to get 710 over 755. Okay. Next one. The probability that the person is a cell phone user, given that, and it's funny, I didn't put that U there, given that the person got a speeding ticket. So probability that they're a cell phone user, given that we know that they got a speeding ticket. Okay, so if we know that they got a speeding ticket, we're automatically going to be in this sample space right here. And so our sample space has been reduced to 70. There's 70 people who got a speeding ticket. So I know that we are only talking about people in that particular column right here. And then which of those are cell phone users? So only looking at this column, the ones who are cell phone users, 25 of them. And so my probability here is 25 over 70 because we only have 70 who have a speeding ticket. Okay. And then our last one here, probability that the person got no speeding ticket, given that we know that they're not a cell phone user. So not a cell phone user is going to be in this row right here. So I'm limited to this row. So that means that there's 450 people total in this row, and I want just the ones who have no speeding ticket in this row. So that's going to be 405. So here we have 405 divided by 450.